I missed the question.
Hello.
Okay, we're gonna go over these. I should stand in the middle so they can see me on the last video. I was like over here the whole time. So, like, it was just like my arm. Alright. Okay. So, multiple choice review. Number 1, which of the following is not an example of simple harmonic motion? A ball bouncing on a floor, a child swinging on a swing, a piano wire that has been struck, or a car's antenna waving back and forth?
A.
A. Why A?
Because it takes less time.
Ryan, you can never answer, can you? Okay.
Wow.
Alright. A mass spring system can oscillate with a simple harmonic motion because a compressed or stretched spring has which kind of energy?
Delta.
Elastic potential. Okay. Alright. Number 3. A child on a playground swings through a total of 32 degrees. So that means like 32 degrees from where they started to where they ended. Not like from straight down. What is the amplitude of this vibration? If it's equal on each side of the equilibrium position. What? Okay, let me draw a picture here. So it goes from, draw a bad child here. There. There. Is 32 degrees. Shh. Quiet guys, that makes sense what?
Yeah.
Okay. So there's the equilibrium position. The amplitude is how far they are from that position. So what is their total what's the amplitude?
64.
Charlie. C.
So we're looking for that angle right there. So B, 16 degrees. Does that make sense to everybody now?
Yep.
Alright. Number 4. How are frequency and period related in simple harmonic motion? They're what? They're inversely related, so number 4 is B. Okay, this next one, you guys see those two diagrams of like the spring being compressed like we did with the slinky the other day? The compressions in the spring are represented by what feature of the wave below it. So when the spring is compressed, what's right below it on the other wave?
B.
B, crest. So the compressions in that spring are represented by the crest of the wave below it. So what would the distance between the two compressions be considered?
A.
A wavelength, yes. So the distance between the two compressions would be a wavelength. Okay, number 6. Each stretched region in the waveform of the longitudinal wave shown above, so that's that picture again, corresponds to what feature of the transverse wave below it. So this time where it's stretched out, what does that correspond to in that diagram? C, the troughs. Any questions on those?
So
Sure.
is 5 A or B because you said both?
Oh, 5 is B.
Okay.
I was asking like a different question.
Instructions different. Okay, I gotcha.
And 6 is C.
Yes.
Okay. Which of the following affects the wavelength of a mechanical wave moving through a medium? Assume that the frequency of the wave remains constant. So you think the nature of a medium makes a difference? Or actually, the equation for the speed of a wave equals the frequency times the wavelength. Does that make sense? So that's the equation we used before. So if the frequency is staying the same, what has to change for the wavelength to change?
The B or the angle?
The frequencies staying the same. So for the lambda, the wavelength to change, the velocity of the wave has to change. Which of those things are going to change the wavelength?
Energy. C.
Yeah, Mrs. Gurney.
Today I have good things.
We have a commercial break as Mrs. Gurney, our chemistry teacher.
CJ knows that.
Now a word from your sponsors.
It is, CJ is.
You have trouble with dry skin. Well, I don't know. I don't know what the product.
You guys want to help Miss Gurney real quick with that stuff?
Sure. Take off.
Do you have problems?
What?
Kids named
I think they're
Brian.
just remote controls.
Are those remote controls?
I'm awkward.
You have the glowing
He takes the light stuff off the
She's
top
like-
and lets you carry the heavy stuff off the bottom.
Oh, I didn't see this up on the bottom.
Is there more? A lot more. You can help.
I
You
can
want
help.
I don't know what it is though.
Okay.
I don't know what this is.
Alright.
It's 4 and 3.
Do you want one of them to come help you?
Don't worry. Ow.
Okay, we'll keep going and
Wonderful.
Go be useful,
class.
Kyle.
They can rewatch. Why don't you have your mom?
they can watch the playback, yes. Okay. Number 7. Alright, number 7. The nature of the medium, A. is what- The nature of the medium will change the speed of the wave, so it'll change the wavelength or the frequency, but in this case, frequency stay the same. Alright, number 8. Which of the following types of interference will occur when the pulse and the figure above meet? So when those two bumps meet, is it going to be constructive or destructive interference, do you think?
Destructive.
Are they going to add together or subtract? They're going to add, so that would be constructive interference. So 8 is B, constructive interference. So they're going to get bigger. Yes, Anna?
About 7. What is the nature of the medium? What does that mean?
That means like you're changing from, for example, like hot air to cold air or something like that. Or like air to glass for light or something like that. Okay, number 9. Waves arriving at a fixed boundary are, so
B.
they're going to be reflected.
Yep.
Do you guys remember from like those little diagram in your notes when you had a fixed point, were they inverted or not inverted?
Not.
They were inverted.
Just kidding.
No.
So B.
So number 9 is C.
C.
See, they are reflected and inverted. So they're upside down. Holy cow, that's a lot of stuff I have to go through. Alright. Number 10. A 3-meter long string is stretched at both ends. If a standing wave... Did I skip one?
Now you're good.
Okay.
Wait, what was
Number 9 was C. A 3-meter long stretched string is fixed at both ends. If standing waves with wavelengths of 2/3 L are produced in the string, how many nodes will be formed?
2, 3, 4.
Okay. This equation, or this question doesn't make any sense, so we're going to skip it because we don't know what L is. Do you guys agree with that? What?
Is it L3?
We're going to pass on that one for now. I'm missing something about
What's
it.
the answer say?
Get it, girl.
Number 10, the answer says D.
Kyle.
Oh, it's your brother. That's not right. I see where
I
you
think
tossed it out.
I think it's supposed to be 2/3 of a, like, L is equal to 3 meters, and it's supposed to be 2/3. We're just going to skip it because, like I said, it doesn't make any sense. Alright, number 11. How many nodes and antinodes is shown in the standing wave above? How many nodes are there? 5. 5 nodes, how many antinodes?
4.
4, so looking for D, 5 nodes, 4 antinodes for number 11. Antinodes are where it doesn't move at all. So those are like the little pinch points on that one. And, or sorry, what would you ask?
What are the antinodes?
Antinodes are where it moves the most.
Oh, okay, so like the big thing.
The big things. Okay. When a column of air vibrates in a pipe that is open at both ends. So if it's open at both ends, all are present. Number 12. So if it's closed at one end is when only odds are present. Okay. Number 13, if a guitar string has a fundamental frequency of 500 hertz, what is the frequency of a second harmonic?
A. So you divide by 2.
It's N is on top though. C, so 1,000.
You divide by
When any, so if you have the equation F equals N times V over 2L. If it's 500, then that equals 1. If we double that, Michael, now that's going to equal 1,000. This part's going to stay the same.
We're gonna multiply it.
Yeah. Does that make sense?
That's bad.
Alright. Number 14. A vibrating guitar string emits a tone just as a 500 hertz tuning fork is struck. If 5 beats per second are heard, which of the following is a possible frequency for the vibration of the string? Okay, shh. Alright. So if you're hearing a beat frequency of 5 beats per second, that means it's 500 plus or minus 5. So which one of those is possible? D. So what would be the other possible one?
505.
505. So the answer to that one is D. The other possible answer would be 505. Okay. Number 15. Which of the following would be most likely to transmit sound with the highest speed? In general, the denser something is, the faster sound travels through. A, so steel and a bridge. Temperature changes things too in a different way. So like when you have higher temperature air, it gets less dense, but the sound actually travels faster because the molecules are moving faster.
So does it travel faster if it's warm or cold?
It travels faster if it's warm.
Okay.
Alright. Number 16. A sound wave is a
Wow.
okay, it's asking for either is it a longitudinal or a transverse wave. Does anybody remember which it is? It's B. Longitudinal is when it crunches like this back and forth, and that's what sound is. The other one is when it goes like this as a transverse wave.
C.
Alright, sound travels faster in air if the air is
Warm.
C, warm.
That's why I asked.
Okay, number 18. Noise canceling earphones are an example of
A.
B, destructive interference. They're canceling out the sound. Okay, this is one we didn't actually go over, but I want to make sure we understand it. Alright, number 19. Compared to a sound of 10 decibels, a sound of 50 decibels has,
B.
it's C.
10,000. That's not right.
Okay, so decibels is a logarithmic scale. So if it goes up 10, it's 10 times as loud. If it goes up 20, it's 100 times as loud. If it goes up 30, it's 1,000 times as loud. If it goes up 40, like in this case, it's 10,000 times as loud.
So
Does that make sense?
it's 10 to like the 4th.
It's 10, yeah. So it's going to be 10 to the whatever to 1, so like it goes up 40 times, so it's 10 to the 4th times bigger. Does that make sense?
For every 10 it goes up, the average is
Alright. Number 20. A 680 hertz sound wave travels in air at 340 meters per second with a wavelength of, so it's going to be, here's this equation. Our velocity is 340. Frequency is 680. So our wavelength is going to be 340 divided by 680. A 0.5 meters for our wavelength. Okay. 21. A sound wave that has a wavelength of 2 meters in room temperature air has a frequency of about
B.
A 170 hertz. Okay, so remember what I told you? If we don't know what the speed of sound is, just assume it's 340. So if the wavelength is 2, So if we have 340 equals F times 2, frequency is going to be about 170. Does that make sense, Abby?
Yes.
Okay. Right? This is kind of a repeat, so hopefully you'll get it right. Number 22, sound is an example of a longitudinal wave. Okay, 23. The amplitude of a particular wave is 4.0 meters. The top to bottom distance of the disturbance is 8 meters. So again, if we have, that's our wave. The amplitude there is 4 meters. That would be 4 meters as well. So the total is 8. Does that make sense to everybody? Okay. 24. When a pendulum clock is taken from sea level to the top of a high mountain, will it gain, lose, or not gain no time at all?
Lose.
Neither.
Lose. Neither. Neither. It's always neither.
No, it wouldn't be neither because then why would they ask?
Okay. So, what's going to change?
Air resistance.
Air?
Not the air resistance.
Height.
Gravity.
I thought gravity was constant.
It is as long as you're staying at the same height. It's always 9.8, and that's a good estimate, but as you get further away from the center of the Earth, it's going to be something a little tiny bit less than 9.8, or what it was at sea level. So our equation for the period is T equals 2 pi times the square root of L over G. So as G gets smaller, what happens to the period?
Longer.
It gets longer.
So you gain time.
You know, it's good. Lose time.
So it takes. So if it takes longer to go back and forth, that means it's going to be behind where it should be, so you're losing time. Does that make sense? So it's C. Okay, number 25. If you dip your finger repeatedly into water to make waves, if you dip your finger more frequently, the wavelength of the waves shortens. Alright, number 26. A sonic boom.
D.
A sonic boom
Finish the question.
is swept continuously behind a plane traveling faster than the speed of sound. Is that one true?
Yes.
Yes. Is produced as the plane breaks through the sound barrier.
Yes.
So, all the above.
Is produced by subsonic particles as well as subsonic projectiles as well as subsonic aircraft.
Sure.
False.
That's C is not true. B is also not true. It is produced at all times when the plane is moving faster than the speed of sound. Does that make sense? So it's not just the instant it breaks the sound barrier, it's always produced as long as it's moving faster than the speed of sound.
But you will hear the sound once because it all.
Yeah, you only hear the sound once because it hits you once then keeps going.
So it's just like one long.
It's just like one long boom and everybody only hears it once.
That's kind of sweet.
So like it's this wave of sound that goes with the plane. It's behind, like
If you were also going the speed of sound, would you be able to hear anything?
What if you're like?
you'd be able to hear nothing like from behind you.
What if you're like in the wave going the speed of sound? Would it just be one long move?
Well, it would be like if let's say you're going the exact same speed as the plane in that sonic boom, it would just be one big high pressure, so you wouldn't hear any of the sound. So the boom is that high pressure wave hitting your ear.
If you were going back and forth.
If you were going back and forth through it, you'd keep hearing it. But as long as you keep carrying with it, oh, I should stand over here, Mike. Thank you. All right. Number 27. A sound wave that has a higher frequency has a wavelength that is shorter. All right. Number 28. A weight suspended from a spring bobs up and down, again over a distance of 3 meters in 10 seconds. Its frequency is, so it takes 10 seconds to go down and up. What's its frequency going to be?
3 It's not a
None of the
debug.
above.
It is something.
It is B.
Okay. It takes 10 seconds to go down and up. So the period is going to be 10 seconds. That means the frequency is what? Well, it's 1 over 10.
1/10.
So 0.1. So the answer is A. So it takes 10 seconds to go down and up. The period is 10 seconds. The reciprocal of that is going to be the frequency, which is going to be 0.1.
So you didn't need the meters.
Didn't need the meters.
Well, that's
Okay. Number 29. A cork floating in a pool oscillates up and down 3 complete cycles in 1 second as a wave passes. 3 complete cycles in 1 second as waves pass by. The wave's wavelength is 2 meters. What is the wave's speed?
C.
Okay, so what's the frequency? 3 cycles in 1 second. Cycles per second is frequency. 3. So if it does 3 cycles in 1 second, the frequency is 3.
It's not a ch.
Wavelength is 2. So C, 6 meters per second. Any questions about any of those? Do you guys feel like you kind of understand what's going on here? Kind of.
Yeah, I think so.